So I want to talk about the physical impact of wearing technology, and I want to introduce the project that Miriam Steele and Hannah Gnafo and a couple of other research assistants have worked on during the last year. To give you a little bit of context, Paul had mentioned Eyebeam, so this is basically from the master class that was exhibited, which was called Matter That Moves, a 3D printed fashion exhibit downtown. This is one of the projects of one of my students at Parsons in the MFA Design and Technology program, Fito Segreiro. This is a project called UV Taste, and it's a wearable mouthpiece that takes UV light and actually makes you taste it. And then this is a project by Lauren Slavic. She calls it Tailor-Aid. It's basically using a Kinect and open frameworks to do body measurements and actually create customized clothing. So that's work that some of my students are doing. But the two strands of thought and the reasons why Miriam and I got together to start this research project was my interest of examining the psychological aspect of wearing technology. And Miriam wanted to use the sensors, basically the physiological input of those wearable technologies, those sensors, to validate the research that she has been doing with the mirror interviews. So quantifying qualitative data sets, basically. So I'm talking about physical implications. As I said before, Miriam and Hannah are going to talk about the mirror interview and its applications. And then Wendy D'Andrea and Stephen Fried going to be talking about the emotional aspects. So my research does a lot or works a lot with three implications. And that's primarily physical implications when you wear. One is wearability. It's basically, can you wear it? How do you wear it? What are the implications of wearing technology? Does it sag, for example, if I have very specific drape? What is the form factor of certain technologies? How can I integrate it? Where do I have to place sensors? Where and how much energy is a certain actuator needing, and so forth. So it's a lot about wearability. It's a lot about the technical implications, but also the ergonomic implications of a technical piece. Then it's about the interaction, so it's about the human-computer interaction basically for clothing. So it's really about, do I need this on and off switch? Where and how do I interact actually with a sensor that is on my body and that I don't necessarily switch on through my actual manual input? And then the aesthetics is, does it actually look good? Does the piece that I wear actually conform to the aesthetic, cultural, social implications that my garment has? Because we all wear garments for these certain functionalities. So for me, the garment is an interface, and it actually is a white blank canvas that is then manipulated through technology. So the robotic arms you see here, to me, manifest the actual technology. So fashionable wearables are, for me, designed garments, accessory, or jewelry that combine aesthetics with functional technology. So one cannot be without the other when I refer to a fashionable wearable. So to me, the body and or our second skin, which is clothing, is always connected. It's a node in a much larger system. So thus going from a body area network now into the wireless sphere. So when we talk about this space, and I want to mention Sherry Turkle, her thought is that contemporary computational objects are increasing intimate machines. And that already was in 2004, and even earlier, some of her writings refer to that. So it's really about the intimacy. So for me, garments actually are very intimate. They're on our body. And so they're very differently to be interacted with than, for example, a cell phone. So in our research project, we're looking at three modes of observation. How can we actually now observe how somebody feels wearing technology, and how can we use those physiological inputs in order to actually validate the interview analysis? So one is we looked into computer vision. If we actually have facial recognition, if we have recognition that, for example, reads our pulse through computer vision, that would be one quantitative data set we can use. The second data set is coming from directly the body, which are vital signs. And then the third, of course, is human observation. That is what Miriam and Hannah are going to be talking about, the mirror analysis, which is qualitative information that then will be quantified, though by the actual observer. Again, I'm using Rosalind Picard's quote, effective computing, but again, here looking into the more pragmatic actual creation of data sets through vital signs, but then actually thinking also about the psychological effects in the actual wearer. So we looked at a lot of different examples. One, of course, the Turing normalizing machine, looking at facial recognition, for example, or the Vivianec Life shirt as an example for using it for capturing vital signs. For those of you who come from Parsons, Daitu Manabe is an example of someone who has, as an artist, who has been using facial recognition in his artwork. So again, we looked, of course, into things like open frameworks and do-it-yourself methodologies and other types of programming in order to make this work. I just want to go into a few vital signs we have been using and we looked at, and Wendy, who will be speaking later, has helped us to identify a few which are the prominent, also used in psychology. But we basically looked into ECG, typical heart rate, which is very easily to be obtained. There are lots of commercial products out there. EMG, which basically determines physical bodily activity. Body temperature, a very easy one to obtain. And speaking of body temperature and a heart rate, things like those can actually go up. Either you are excited or you are extremely frustrated. So how can we actually create an algorithm to understand the different emotional functionalities of these vital signs? So that is where we have to correlate a lot of different aspects, and that's why facial recognition actually comes into play and is an interesting aspect, because through facial recognition, we can actually correlate some of these data sets to either a positive or a negative emotion. EEG, the state of consciousness. A lot of you probably have seen all these NeuroSky type headsets out there that people use for art projects and for neurological examinations. Heart rate variability, another one, which is really thinking about and looking at a heart rate over time, which of course is very interesting because every aspect, every sensory data set we're using over time actually is almost like machine learning. We understand a person's vital signs much better the more and the longer periods of time we can actually monitor a person. Certain emotions can be detected. Galvanic skin response, for example, can be detected through sweat, for example. Again, this is something depending on whether, depending on your emotion, depending on your activity, you sweat or you don't sweat. And again, this needs to be correlated. Then we can use an accelerometer to figure out, is it actually through a physical activity that you start to sweat, or is it an emotional context that you start to sweat? Two completely different reasons why somebody would sweat. Blood pressure, again, something that is very ubiquitous and out there pretty often. Respiration, again, the same thing. Am I breathing because I'm excited? Am I breathing fast because I'm out of breath, or I'm like, extremely anxious about something? And accelerometer and gyros, I think everybody who is in the DT program at Parsons knows what that is. Things that we also looked at is what are the possible devices that we could use. So of course there's a do-it-yourself device, the Bitaloni, is a do-it-yourself biosignal system that you can easily purchase. Also looking at Shimmer, which is actually a modular sensor suite that is used for data collection. You can actually create your own set of sensors. And of course, we also looked at products that are out there in the space. Something like the polar heart rate sensor, which has been one of those, one of the first ubiquitous products looking at heart rate and have been reappropriated and used and hacked in and used for many different projects. Jawbone, Misfit, typical tracking devices as we see them right now. primarily tracking motion. The OM Signal shirt that was just released by Paula Ralph Lauren, Susan has shown it before, and you also see it on the invite, captures heart rate, breathing, and HRV. And then Atos is actually also a shirt that is released. It's measuring muscle activity. It actually has sensors throughout the entire shirt, heart rate and breathing, and it's really also used for sports. So you have a lot of those type of measurements and a lot of those type of commercial products, of course, now in the market, in the sports market, as you guys know. But we want to reappropriate those. So without further ado, I want to acknowledge the research assistants on this project, Hannah Naffel, who will also speak right after me with Miriam. Stephanie and Ayo have been, or are students, second-year students at the MFA Design and Technology program at Parsons. Lauren Gomez just graduated last year from the MFA Fashion Studies program at Parsons. And I want to give a big shout out to Sean Montgomery, who helped us quite a bit from Produce Consume Robert, who unfortunately is traveling. And you can reach me at this email and Twitter.